Enzymes are proteins that act as biological catalysts. Basically, their job is to speed up reactions in living organisms. Some examples are amylase, which is used to break down amylose, which is just another word for starch, lipase, which breaks down lipids, and protease, which breaks down proteins. You might notice a bit of a trend there that they all end in ase, A-S-E. It's very common for enzymes to be named like this. So here's how they work. First of all, it's important to realise that enzymes have got a really specific shape. And they've got this important part of them known as the active site. And the active site is the place where a substrate is going to bind. Now, then a substrate is just a fancy word for the thing that is going to get broken down by an enzyme. We just explained that amylose gets broken down by amylase. In that example, amylose, or starch, would be an example of a substrate. What happens is the substrate will join with the active site, and when this happens, we now describe this whole thing as the enzyme-substrate complex. What basically happens is the bonds that are joining those bits of the substrate together as one get weakened. It's basically easier to break up those bonds once it's become joined to the active site. This allows the pieces to become separated, and now we've got products. So as a summary, it kind of looks like this. The enzyme binds with the substrate to form an enzyme-substrate complex, then the products are released, and the enzyme remains unchanged, ready to go on and continue working and doing the same job over and over again. If an enzyme becomes exposed to heat, it is possible that it might end up getting changed. It might end up having its shape changed. This means that the substrate would no longer be able to join with the active site, and therefore the enzyme wouldn't be able to do its job. When this happens, we say that the enzyme has become denatured, and usually this is permanent. Once an enzyme's become denatured, it can't convert back and become the original shape and become useful again. We can see that as the temperature increases, the rate of an enzyme catalyzed reaction will initially increase. The reason is that as this happens, we've got an increase in kinetic energy. That means that all of the molecules are going to be moving around at an increasing rate, which means there are going to be more successful collisions between the active site and the substrate. However, once the temperature gets too high, the enzymes will become denatured, and then we have this sharp drop in reaction rate. That sweet spot in the middle where there is this balance between increasing kinetic energy, but where the enzymes aren't denatured, we have this peak of reaction rate, and this is known as the optimum temperature. Another way to change the rate of an enzyme catalyzed reaction is by increasing the substrate concentration. Obviously, if we put more of a substrate in there, we are going to have more collisions between substrates and active sites, and therefore there is going to be an increasing rate of reaction. However, eventually this will start a plateau, because if we keep adding substrate in, we're going to find that all of the active sites are occupied, and therefore adding more substrate is not going to improve the rate of reaction.